Hello, I'm Fran. This is the Vernier Go Direct sensor cart. The sensor cart includes an encoder wheel on the bottom that allows it to measure its position both on the track and off the track. It also includes a force sensor with plus or minus 50 Newton sensitivity and a 3-axis accelerometer. It comes in two colors, teal and chartreuse, or for convenience, green and yellow. In addition, both versions have a plunger, and the plungers have the super elastic collision feature that's also available on our other plastic plunger carts. I'm going to do 3 experiments for you that you can do with the sensor cart. So let's take a look. In order to use the sensor cart, I'm going to turn it on. The red light blinking indicates it's ready to connect via Bluetooth. So in graphical analysis, I choose sensor data collection. I'm going to look for the ID number of this cart on my sensor list. In this case is the one that ends in 0003. And the channel that's automatically connected is the position channel. On the cart itself, we've got an arrow that marks the positive X direction for position. In this case, I'm going to have that arrow pointing up the ramp. I'm going to zero the cart in this location, so it treats the end of the ramp as the 0 location, and then collect some data. As you can see, these graphs are very smooth. I can determine the acceleration by looking at the slope of this graph by choosing the curve fit option. Or I could also show the acceleration graph as a third graph. The acceleration graph is also extremely smooth and would give a very good average value. The second experiment I'd like to do is a momentum and impulse experiment. To do this, I'm going to have to do a little bit of setup. Level my track. And I'm going to enable the force sensor on my cart. In addition, I'm going to add one of our hoop springs so that the cart will bounce off the end stop at the end of the track. In this case, I'll have the arrow pointing the opposite direction. To enable the force channel, I'll go back to my sensor settings and enable that channel as well. Now my 3 graphs will be a force graph, a position graph, and a velocity graph. Once again, I'm going to zero the position of the cart, and I'm also going to zero the force reading so that while no force is pushing or pulling on the cart, it will read 0. Again, we see very smooth graphs. I see a force, I see a position graph that shows going away and then bouncing back the opposite direction, positive velocity followed by negative velocity. I'm going to determine the impulse by getting the integral of the force graph. The integral of the force graph is negative 0.286 Newton seconds. I could compare that to the change in momentum of the cart by multiplying the mass of the cart times the initial velocity going towards the barrier, and then multiplying the mass times the final velocity coming away from the barrier, and looking at the change in momentum. My third experiment is going to be a collision involving 2 carts. For this, I'm going to start a new experiment in the software. I need to find my yellow cart. on the list of sensors and connect to it. And in this case, when I have the collision between the two carts, I'm going to want them to bounce off of each other. So I'm going to replace the tabs with some tabs that include magnets. There they are. I'll disable the force on the green cart because we're just going to look at conservation of momentum for this collision. Typically, when you're doing a collision experiment like this, you'll want to zero the positions of the two carts at the point where they'll collide. So I'll zero these carts here. Leave the green one in place and get the yellow one ready for the collision. I'd like the positive direction for this collision to be this direction. So my yellow cart is already set up for the positive direction to be that direction, but my green cart is facing the opposite direction. So I'm also going to reverse the direction on the green cart. Now I'm ready. As you can see from looking at the graphs, we have a very nice transition where the first cart was moving while the second cart was stationary, and then they switched roles with the yellow cart coming to a stop and the green cart starting to move. You can also see that from looking at the velocity graph. I'm sure you could think of many more experiments that you could do with Go Direct sensor carts. We'd love to hear about them. You can find more information about these carts on our website.